One of the most famous stars we can see, Betelgeuse, is set to go supernova extremely soon.
Astronomers think that we could actually be seeing the death throes of that star before it goes supernova.
Scientists detected previously unseen supernova remnants in a patch of the night sky.
Get ready for an incredible experience as we witness the explosive transformation of Betelgeuse, a red supergiant star. This cosmic event will light up the night sky, and it's sure to be an unforgettable spectacle. Scientists are also working to solve the mystery of why Betelgeuse has been getting dimmer lately.
We were talking about this during the break. This created a one-of-a-kind eclipse. The star is Betelgeuse, a red supergiant in the constellation.
And they may have found some answers. How would this supernova change our knowledge and picture of the cosmos? Join us as we explore the Betelgeuse explosion that is expected to take the night sky all over the world. Betelgeuse Explosion. NASA announced that Betelgeuse, a big orange megastar, will go supernova soon. Supernova explosions like this happen often in space, but we've never had a chance to study one up close. In 2019, Betelgeuse blew off its surface and had a massive ejection. Recent activities suggest it's getting ready to explode, and we have a rare chance to see it with our own eyes. On December 12th, an asteroid named Leona will pass in front of Betelgeuse, blocking our view. This special event can be seen in a narrow area from southern Florida to Europe, letting many see Betelgeuse become less bright or disappear. This special time, called an occultation, is a great opportunity for scientists to study Betelgeuse closely. Astronomers think the star's surface is like a mess of big moving cells that affect its brightness. These patterns might make Betelgeuse explode supercosmically, either in our lifetime or thousands of years from now. When the asteroid Leona passes before Betelgeuse, scientists hope to learn more about these messy features and understand the processes that could make the star explode. Betelgeuse. Betelgeuse, a name that has traveled through time, takes the spotlight in our night sky. Settled within the Orion constellation, it is approximately 650 light-years away from Earth. Belonging to one of the largest and biggest classes of stars in the universe, it is grouped as a red supergiant, whose actual size dwarfs our Sun, undoubtedly making it a superb giant. It is one of the largest supergiants visible to the naked eye. In 1920, Betelgeuse became the first extrasolar star whose photosphere's angular size was measured. Betelgeuse has a unique orange-red color that makes it easy to spot at night. It's part of the winter triangle, serving as the center of the winter hexagon. After sunset in January, you can visibly see it rising from the east. It's visible from September to March, with the best view in mid-December, except in Antarctica, where the latitude is below 82 degrees south. Depending on where you are located in May or June, you can briefly see the red supergiant on the western horizon after sunset. Its confusing behaviors and particular features have intrigued astronomers and stargazers for ages, making it a specimen of several analyses and studies. Each time we focus on it, we return in time because of its distance, which is 6 quadrillion, 150 trillion, and 650 billion kilometers away from us. It's like taking history lessons because the presence of Betelgeuse in today's night sky is 240,500 centuries old. Betelgeuse's tenure as a red supergiant is a subject of astronomical estimation, relying on assessing mass loss rates, observed circumstellar material, and the abundance of heavy elements at its surface. While providing valuable insights, these metrics also introduce challenges due to Betelgeuse's dynamic behavior. Estimates suggest that Betelgeuse may spend anywhere from 20,000 to a maximum of 140,000 years in its red supergiant phase. These calculations involve intricate considerations, including examining mass loss rates and assessing circumstellar material. Betelgeuse, characterized by sporadic periods of intense mass loss, adds a layer of complexity to these estimations. The star's status as a runaway star, hurtling through space at a high velocity, further complicates efforts to precisely gauge its current mass loss in comparison to the overall mass it has shed over time. This dynamic movement through space challenges unraveling the complete story of Betelgeuse's evolution. Betelgeuse's journey as a red supergiant remains a compelling astronomical puzzle, where estimates, though insightful, continue to be refined as our understanding of this stellar giant deepens. The Great Dimming. For a star as gigantic as the red supergiant, as expected, it shined brightly. So when it suddenly started dimming between October 2019 and early 2020, it stirred up commotions in observatories worldwide as astrophysicists and stargazers scampered around looking for answers that explained why it was happening. Betelgeuse went from shining so brightly to almost not shining at all. The difference was evident even to the naked eye. Interesting and mind-boggling questions have been flying around, but whether this dimming primarily prepares us for the long-awaited Betelgeuse supernova explosion. Typically, red supergiants are known to be quite flexible in how bright they shine. However, the difference this time was exceptional. The Great Dimming has raised several theories in the scientific world, including a tremendous release of gas and dust from the Betelgeuse surface, which is the reason for the dimming. Sounds like shedding off some weight. Some other scientists have considered there to be an enormous spot on Betelgeuse's surface, where the temperature dropped drastically, resulting in a decrease in brightness. A group of scientists worldwide took it upon themselves to investigate and get answers. Kenichi Nomoto led the group from the Kavli Institute for the Physics and Mathematics of the Universe, where they discovered that Betelgeuse may be smaller and closer to Earth. The team proposed that a dust cloud caused the dimming further, causing more intrigue. While this team worked diligently, another team, led by Hideyuki Sayo at Tohoku University in Japan, began their meticulous investigation. They presented a different perspective on Betelgeuse's rhythmic pulsations. This suggestion explains that, like a heart, Betelgeuse expands and contracts, which causes irregularities in its brightness. This red supergiant luminosity followed a particular routine, a cycle of almost 420 days, as a result of its outer envelope constantly swelling. During this search and investigation, Betelgeuse's brightness returned as we know it, ending the drama but leaving astronomers and stargazers even more confused than they were when it first dimmed. During the dim, a temperature drop was observed, and researchers also found sunspots on our sun. It is believed that the star spots on Betelgeuse could have caused the temperature drop, as it was observed that the star spots are in the same locations where temperatures dropped drastically. These star spots are the universe's anomalies that impact the radiative output of the star. Just like the sunspots on the sun, the cooler areas on Betelgeuse's magnetic field could have a great effect. The irregularities in the star's magnetic field, greatly impacted by the appearance of these star spots, may have restricted the flow of radiation from the Earth's core in the meantime. This intervention caused a drop in temperature. It caused a drop in temperature, as observed. It's an otherworldly play of cause and effect, where the difficult interaction on the star's surface plays a significant role in its luminosity. However, these discoveries don't end with Betelgeuse. They have brought more awareness to red supergiants, known for their remarkable sizes and their essential roles in creating the universe's heavy elements, referred to as metals in astronomical language. The formation of these metals in red giants is a crucial step in contributing to the cosmos's supernova chemical makeup. Identifying the impact of star spots on temperature and radiation blocking will give astronomers a better understanding of the systems at work in red giants. Furthermore, the dimming of Betelgeuse that equally resulted in a temperature drop ignited curious excitement in the astronomical community, raising many ideas and theories that are creating a new perspective on what we already know about the red supergiant. Anyway, the Great Dimming could mean something even more. The big question is if the dimming is related to a supernova. However, that isn't always the result, because a star's dimming is part of its life cycle and has several unknown causes. Supernova prediction. A supernova is a destructive event that occurs when a gigantic star comes to the end of its life. To back this up are history and theories that link us up to dimming occurrences and the possibility of a supernova, as many stars that go supernova evolve to the phase of related red supergiants. In this phase, they go through differences in brightness levels, which include temporary dimming owing to several processes happening on the star's outer layer, like pulsations and changes in convection. These details were obtained from diligent research and monitoring of red supergiants for any indication of a forthcoming supernova. It is noteworthy that massive stars display unusual behaviors when they exhaust their nuclear fuel and are close to a supernova. But that isn't a common step. As not, all dimming leads to a supernova. In some cases, dimming occurs in stars due to natural differences in their brightness. Betelgeuse is a red supergiant that has evolved from an O-type main sequence star. Its core eventually collapses, producing a supernova explosion and a compact remnant. The details depend on that main sequence star's exact initial mass and other physical properties. The cause of Betelgeuse dimming remains unknown, but working with the assumption that it was related raises another crucial question. Can a star come back to life even on the verge of a supernova? The answer is a resounding no, because once a star reaches the point of a supernova, it has exhausted all of its nuclear fuel and gone through significant changes in its core. These changes are typical of a supernova, and there has been a reversal so far. The life cycle of a massive cycle follows this progression. It begins as a main sequence star where nuclear fusion in its center changes hydrogen into helium, providing the star with adequate energy against gravitational collapse. When the star runs out of hydrogen, it starts contracting and heating up. This will lead to helium fusion into elements such as carbon and oxygen. The fusion will continue, resulting in heavier elements until iron is created, which cannot release energy through nuclear fusion. This iron accumulates until it reaches the Chandrasekhar limit, where it can no longer support its gravitational forces and soon collapses, known as a supernova explosion. The energy released during a supernova explosion is so immense that it outshines an entire galaxy for a short time and destroys the star, leaving behind small residues such as a neutron star or, in cases like Betelgeuse, a black hole. In situations where dimming is reversed, it can be said it isn't related to a supernova, and that brings us to what scientists recently revealed that seems more plausible. High-resolution images of Betelgeuse were captured with a powerful Matisse instrument on the European Southern Observatory's Very Large Telescope, Interferometer, in the remote area of northern Chile from December 2018 to December 2020 by a team from France's Université de Côte d'Azur. After capturing and recording the events of the Great Dimming, they presented another narrative in October 2023. They explained that the dimming occurred due to a thin layer of dust, made up of silicon monoxide covering Betelgeuse's brightness. Their findings concluded that the dimming was a natural occurrence and not a forthcoming explosion. Their discoveries support a 2021 study that found gas erupted from Betelgeuse due to an unexpected fall in temperature. As a result, solid dust was formed, wrapping the star and casting a shadow over it. Even more fascinating is that these dust clouds eventually produce new stars. To answer whether Betelgeuse will go supernova, the answer is no, because if it will, it already happened centuries ago, and we only just got to see it now. The event that occurred in 2019 happened 600 years ago in the star's life, and Betelgeuse has returned to its usual radiant brightness. However, we do not rule out the possibility of a supernova ever happening, but there is no time speculation when that will happen, so like everything else, we wait with fingers crossed. Still speculating are researchers that believe Betelgeuse is still in its helium-burning phase. This theory would mean that a grand performance is still expected, a supernova of epic proportions. This theory is based on studies from Hungary's Konkoly Observatory, led by Kenichi Nomoto, from the Kavli Institute for the Physics and Mathematics of the Universe. But we have a different twist to the story. Another theory by Dr. Hideyuki Sayo stipulates that Betelgeuse is undergoing a carbon-burning phase rather than a helium-burning phase. It gets even better. He speculates that Betelgeuse will surely go supernova in only a few decades, causing an electrifying sensation. Whether this explosion happens sooner or later, based on this theory, we are made to believe that the night sky will be displayed with an outstanding spectacle of epic proportions that can't be missed. The eventual explosion of Betelgeuse is a fatal process that results in a supernova, one of the universe's dynamic events. When it occurs, there is an extreme release of undetectable subatomic particles that reach Earth before the visible light of the explosion. Of course, this won't be much of a spectacle. It will be like a supernova. The supernova promises to be a spectacular display that will captivate every eye. An unexpected flare will overshadow the moon and be very visible during the day, even with the sun shining brightly for weeks. It won't be stable. It will only shine. It will go through phenomenal changes in displaying colors and the intensity of its brightness, creating a celestial light that captivates every imagination and providing stargazers with the once-in-a-lifetime opportunity to witness celestial fireworks in the sky. What comes after is equally as interesting. When a star goes supernova, it takes one of two possible routes. Which way will Betelgeuse go after supernova? Once more, we find ourselves etched to the front of our seats with fingers crossed. What next? After the supernova, one of the possible routes Betelgeuse will take beyond its explosion is the creation of a neutron star, an incredibly solid yet unfamiliar object that, owing to its core, is gigantic enough to form a black hole surrounded by the outline of the event from which no light can escape. A neutron star is incredibly dense, packing about 1.4 to 3 times the mass of our Sun into a space roughly the size of a city, typically around 20 kilometers in diameter. Neutron stars are composed almost entirely of subatomic particles found in atomic nuclei. On the other hand, a black hole is incredibly dense and has such a strong gravitational force that not even light can escape from it, making it appear black in the night sky, as they do not emit any detectable radiation. Which fate Betelgeuse will take remains to be seen. Studying Betelgeuse and its impending supernova is not about witnessing a spectacular event. It's about unraveling the complex processes that govern the life and death of stars. The knowledge acquired from this cosmic occurrence will enhance our comprehension of cosmic evolution, the creation of elements, and the high-powered features of our universe. Betelgeuse, at present, plays varying roles. One is a spectacularly exclusive laboratory in the expansive cosmic stage, providing us with an excellent viewpoint to witness one of the most energetic events in the cosmos. Also, it plays a spectacular role that will soon grace our skies. In the grand cosmic theater, patience is our virtue. Though unpredictable in its cosmic timing, Betelgeuse reminds us of the profound mysteries that await our discovery in the night sky. As we await the Betelgeuse supernova explosion, we remain vigilant and curious, knowing that when the moment arrives, it will be a cosmic fireworks display that transcends time and space, leaving an indelible mark on our understanding of the universe. Let us know what you think in the comment section. Remember to like, share, and subscribe for more content like this. See you next time.